එතකොට data encoding techniques කියන ඒවලදී අපි කතා කරන කොහොමද data signal වලට transmit කරන්නේ. So we were discussing couple of right. So the first technique that we have discussed is called non-return to zero level, or in short, we say NRZL. Right. Now, in this representation, we are going to look at how the data is represented. So in this example, you can see we have a set of data which represents 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1. So the technique in NRZL, we are using two different voltages for 0 and 1. Right? For example, here, if this line is a voltage and this is the timeline, so the low voltage represents 0, high voltage represents 1. So the signal should look like this. So during 0, it's a low voltage. During 1, we have high voltage. Again 0, low voltage. 1, high voltage. 0, low voltage. Then 1, high voltage. 1, high voltage. Then low voltage, low voltage. High voltage, high voltage. Right. That's one way to do this. The second one we call non-return to zero inverter. So in this technique, we will represent again using 0 and 1, right? But in this case, we will have transitions, right? So 1 means you have a transition. Transition means if it is 0, it will change to 1. If it is 1, it will change to 0. So if it is 0, no change. Okay. So assuming that you start with the low voltage, when you say 1, you need a transition. When you say transition, you go from low to high. But then you have 0. 0 means no transition. You go along the same line. Then you have 1. 1 means you have to transition. So that means you go from high to low. 0, no transition. You go with the same. 1, high. Then again 1, then it will be low. No change for 0, no change for 0. Whenever you want, you have a high. Whenever you have high, the transition, you will go. Right. The next one that we are going to discuss is called Manchester encoding. So this is another way to represent, right? So people actually came up with a different technique. So the third one is called Manchester. Now, when we talk about the Manchester encoding, it says voltage change from low to high for 1, high to low to 0. But this happens in the center, right? So first one is 0. 0 means high to low. 1, low to high. 0, high to low. 1, low to high. Then 0, high to low. 1, low to high. 1, low to high. High to low. High to low. Low to high. Low to high. So you see now how it actually represented. Right. Now, another problem that we are going to face usually when you are sending data in any network, anyway, there could be errors. So next phase, we are going to discuss how we could, check the errors. So this is what we are going to discuss under error detection. So when we talk about the error detection, we will have any signal may change. Flip means it goes from 0 to 1 or 1 to 0. Now let's assume that these two signals, we have original signal, it goes like this. Let's assume the first representation is like 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1 like this. But let's say you receive the signal and there's error. The error is originally it was low, but when you transmit, it becomes high, right? So detecting this error is we call error detection. पर මෙතනදී පොතේ මේ signal එක low තිබුණ එක high වෙච්ච එක තමයි අපි error එකක් කියලා කියන්නේ. ඒක කොහොමද detect කරන්න කියන එක තමයි. This is called error detection. So this error we should be detected. So this is exactly what we are going to discuss. So there are, different ways that we can actually check this. But the simplest one we are going to discuss. So this process, we call it error detection. That means you detect that there's an error, and correction, we call error correction. Okay, so let's start writing a simple way of checking this one. This is called parity check. Let's take down parity check. Now, parity check means simply we are trying to identify what the error is, right? So this is a simple one, one of the simplest way to check this one. So simply we will check, I will explain, using a way to check whether this is a even or odd. So let's take down, then I will explain. So this is one of the simple ways to represent, which we call parity check. Right, we call it, it's a parity check. So we are going to use an additional bit for this, right? Now additional bit means now we have a bit pattern. අපේ ones and zeros තිබුණ එකට අපි තව එකක් වැඩිපුර එකතු කරනවා. මේ parity check කියන එක check කරගන්න. හරි? parity check කියන එක check කරගන්න. තව එකක් අපි add කරනවා. දැන් අපි ඒක ගැන තමයි මෙතනදී කතා කරන්න යන්නේ. පුතා ලියාගෙන ඉවරනම් මට කියන්න. Right. Okay. Now, what we are going to do is, as I told you, you are going to add a one bit to this one, right? So, so there are two ways I told you. You can have even parity or odd parity. I will explain the two. So I will start by saying parity check. Right. So this is what we are going to do. And then under this one, we are going to look at the data representation. Right. We'll start with the data. In this example, I'm going to represent the letter A in ASCII. මතක නම් කියන ASCII වලින් අපි A represent කරේ කොහොමද කියලා?
65 වලින්.
And 65. Right. Then we have something called parity bit. Then we have what we call parity bit. I will explain all this. Then we have encoded data. Remember, we talked about this encoding earlier, like how do you represent this data, and some remarks. Right. Right. Now let me start with this one. Now, when we say parity check, there are two types. First one we call even parity. Now, simply even parity means you add a bit to make your number a even number. I will explain. Now, we know from ASCII, right, that we have 65. So using how many bits, Kanta? 65. How many bits we need? ASCII, how many bits we are using?
7-bit.
7 bits exactly. So we have 1, 0, 0, 4, 5, 6, 7. It goes like this, isn't it? So this is code. This is what we want to say. Now this is for even parity. Now when you say even parity, you add all the bits together and whether you check whether it's an even number. Now we have 1 and 1. When you add, you have 2. So 2 means it's even, right? So we have an even parity. So even number. So if you have even, then parity bit will be 0. Because this parity bit could be either 0 or 1, depend on what value you are getting. Currently, we are getting even number, so we don't have to add anything. So your parity bit is 0. Right. I will put a color to this. Let me say this is in, okay, red color, right? So now what you do, usually you will get this original number, right? And then you add a parity bit. In this case, right, you are going to add a parity bit. So that means, so the first bit will be 0. It should be the first bit, right? I put it like this. So you add these two together as the first bit. Now this is a even number. When you add it, you are getting even number. 1 and 1, this is 2. Right. Simply what you do is you add it, right? You add the numbers. If it is even, we say there's no errors. It's called even parity. You go like this. So your number, final number is like this. So even parity means you get a number or whatever the data that you want to send. You check whether it's an even number. If it is even number, you put 0. If it is an odd number, you put 1. So that the finally encoded data, you have to have even value. So when you add the numbers together and the value is even number, then there is no errors according to even parity. තේරුණාද පුතේ මොනවා හරි අයත් නොතේරෙන දෙයක් තියෙනද පාරක් මම එක්ස්ප්ලেইন කරන්න ඕනද? right. මේක ලියාගෙන ඉවරනහම කියන්න පුතේ මම ඊතුරු ටිකට යන්න.
එතකොට ඒක සාහිත්‍යවල හරිද? මම හිතන උනා සාහිත්‍යවල අපේ ගෝණ අපිට තියෙනවා ගෝණ අපිට තියෙනවා.
right. Okay. මේකෙම අනිත් පැත්ත තමයි අපි ඊළඟට කතා කරන්න යන්නේ මේකට කියන odd parity. So in odd parity, you will check whether this is a odd value when you add it up. If it is an odd value, then you don't add anything. If it is even, then you put one. So now you know what will be in when you have odd parity, right? So let's take odd parity. So what odd parity means, right? In odd parity, the value should be odd number, right? Now this number should be odd number, but we already know that this is even. So if it is even, then what should be my parity value? Kanta?
0.
නෑ. මෙතනදී දැන් මේක ඉරට්ටේනේ එන්නේ මේ දෙක එකතු කරපුවාම. ඕනේ ඔඩ් වෙන්න. මේක මොකක් වෙන්න ඕනේ?
1.
මේක 1 වෙන්න ඕනේ නේද? හරි. එතකොටනේ දැන් මේ දෙකයි මේකයි එකතු නම් 3ක් වෙන්නේ. right? ඒක නිසා මේකෙදි වෙන දේ තමයි හරි. මේ දෙක එකතු වෙලා තමයි හරි අපි නම්බර් එක හොයන්නේ. ඒකට දැන් කලින් එකේදී බිඳුව වුණා වගේ මේක ඔඩ් වෙන්න නම් මේකට එකක් එකතු වෙන්න. හරි. එතකොට තමයි මේක ඔඩ් වෙන්නේ. තේරුණාද? දැන් මේක උදාහරණයක් විදිහට අපි හිතමු මේකේ මෙතන තිබි බිඳුව කියලා. එහෙම වුණා නම් මේක ඔඩ් නේ. මේක ඔඩ් වුණා නම් මෙතන එන්නේ. දැන් මේක ඊවන් වුණ හින්දා තමයි මේක 0. ඔඩ් පැරිටි කියේදී අපිට වෙන්න ඕනේ මේක එකතුව ඔඩ් වෙන්න. මේක ඊවන් වෙන හින්දා එකක් එකතු කරගන්න. දැන් මේක හරිද?
හරි.
right ලියාගමු. දැන් මේකෙදි වෙන්නේ ඔඩ් පැරිටි අර කලින් වගේම තමයි
මොකද කිව්වේ? thank you. Thank you.
පුතා ලියාගෙන ඉවරනම් මට කියන්න.
Where is it?
Right. Now that we have discussed even and odd parity, this is something that we are going to check, right? So let's start with a small exercise. Let's see whether you have understood this one. So I'm going to give you a small exercise. And what you are supposed to do here, given the error detection method, I want you to see whether there's an error or not. Right. Right. So I will give you three things: the data, and what is the error detection technique. Right. So this is the first one, the data, and the error detection method is even parity. Right. Tell me whether there's an error or not. Error එකක් තියනවද නැද්ද කියලා තමයි මට පුතාගෙන් දැනගන්න ඕනේ.
පළවෙනි error එකක් නැහැ.
හ්ම්.
දෙවෙනි error එකක් තියෙනවා.
හ්ම්.
තුන්වෙනි එකේ නැහැ.
තුන්වෙනි එකේ මොකද කියන්නේ?
නැහැ.
දැන් මෙහෙමයි. මේ ටික එකතු කරාම මේක even the odd
Even.
even. ඒ කියන්නේ error එකක් නැහැ. අපිට කියන්න no error. No error. දෙවෙනි එක
error එකක් තියෙනවා.
ඔව් තුනක් කියන්නේ odd. අපි බලන්නේ even ද කියලා. ඒතර even එක බලන වෙලාව odd එකක් එන්න බෑනේ. ඒ කියන්නේ මෙතන error එකක් තියෙනවා. So there's an error. Right? There's an error. අන්තිම එක error එකක් තියෙනවද නැද්ද?
එතකොට සර් මේ එකතුවට අර අපි චෙක් කරන පැරිටි චෙක් එක දාලා අර බිඳුව හරි එක හරි එකතු කරලා බලන්න මේද ගන්න අවසානට.
නෑ නෑ දැන් මේක තියෙන්නේ ඒ එකතු කරපු එක තමයි. දැන් data receive කියලානේ කියන්නේ. අපි කලින් එකේදී පොතේ කිව්වේ අපේ data එක යවන්න ලෑස්ති කරන විදියනේ. ඒකට අපි data එක මෙහෙමනම් parity එක even නම් අපි මේ අගය ඉරට්ටේ වෙන විදිහට ඉස්සරහට bit එකක් එකතු කරනවා. ඒ bit එක 0 වෙනවා මේකේ විදිහට. මොකද මේකේ දැනටමත් එකතුව ඉරට්ටේ නිසා. මේකේ ගත්තාම මේකේ අගය එකතුව ඉරට්ටේ. නමුත් අපිට ඕන odd වෙන්න. ඒක නිසා තමයි මේක එකක් එකතු කරන්නේ. දැන් මේ අපිට දීලා තියෙන්නේ data receive කියලා. data receive කියන්නේ data දැන් හම්බෙලා තියෙනවා. දැන් මේකෙදි බලන්න ඕනේ මේ හම්බෙච්ච data එක මොකක්ද? ඒක odd evenද
තුන්වෙනි එක no.
තුන්වෙනි එකේ error එකක් තියෙනවද නැද්ද? yes ද no?
No.
ඇයි no කියලා?
error එකක් තියෙනවා. ඉවන්නේ
තියෙනවනේ මේකේ තියෙන දෙකයි.
ඔව්.
ඒ කියන්නේ මේක even නේ අපිට ඕනේ odd වෙන්න. එහෙනම් මේක කියලා එකක් තියෙනවා. එහෙනම් මේකෙදිත් අපිට කියන්න පුළුවන් yes කියලා. එහෙනම් මේකෙත් error එකක් තිබෙනවා. තේරුණාද දැන්? හරි. හැබැයි මේකෙන් අපිට කියන්න බෑ කොතනද error එක කියලා.
බෑනේ
ඒක කියන්න බෑ. හරි. හරි. එහෙනම් අපි කතා කරා පුතේ මේකෙදි error detection කියන එක. හැබැයි correction අපි කතා කරේ නෑ මම අපි පුතාලගේ මට්ටමේදී error එකක් මොකද correct කරන්න කියන එක තාම අපි කතා කරන්නේ නෑ. ඒක නිසා. හරි නේද පුතේ?
හරි
right. මේ section එකත් එක්ක අපි 6 3 section එක ඉවර වෙනවා. මේ section එක අපි කතා කරේ කොහොමද data import කරන්නේ using signals කියලා. අපි මේකේ අතරේ කොහොමද එක එක ක්‍රමයට මේවා සිග්නල් වලට පරිවර්තනය කරන්න කියන එක කතා කරා. ඊළඟ එකේදී 6.4 වලදී අපි කතා කරන්න යන්නේ මේ PSTN එහෙම නැත්නම් public switch telephone network කියන එක ගැන තේරුම් ගන්න යනවා. ඒ කියන්නේ සාමාන්‍ය ටෙලිෆෝන් ලයින් වලදී එහෙම නැත්නම් ඉස්සර අපි දැන් තියෙනවා වගේ අපි wired connections තියේදී කොහොමද මේක සිද්ධ වෙන්නේ කියන එක අපි කතා කරන්න යන්නේ. හරි. ඒත් මේක හරහා කොහොමද දෙකක් එකට එකතු වෙන්නේ කියන එක. එතකොට සාමාන්‍යයෙන් මේකෙදී analog devices කියලා අපි කියන්නේ ඒ කාලේ විදිහට මේ දෙකක් කනෙක්ට් වෙන්නේ කොහොමද කියලා කතා කරමු. ඒක යටතේ ඔය අපි තව කතා කරනවා modulation සහ demodulation. ඒ කියන්නේ අපිට ඇනලොග් එකක් නිසා ඒක ඩිජිටල් කරගන්නේ කොහොමද? ඩිජිටල් ඇනලොග් කරගන්නේ කොහොමද කියන එක අපි මේ කොටසදී කතා කරන්නේ. right. හරි. let's start. The 6.4 මේක අලුත් කොටසක්. අපි ඒක නිසා පටන් ගමු. මේකේ මාතෘකාව ඉන්නේ මේක 6.4 public switch telephone network. නැත්නම් PSTN කියලා අපි හිතන්නේ. මාතෘකාවක් විදිහට ලියාගමු. public switch telephone network. එහෙම නැත්නම් PSTN කියන්නේ. හරි. So let's start with this one. So usually PSTN network, we have different ways of connecting. For example, when you take two telephones, you will see our telephone is normally connected to the cables, usually overhead lines we call it, or sometimes you have underground lines as well, right? So what happens basically, it will connect telephones with a single wire, right? But they are not, two telephones are not connected directly, right? And the main thing is we need to send voice signals. අපි සාමාන්‍යයෙන් phone lines දෙකක් ගත්තාම ස්ථාවර අපි දුරකථන කියලා කියන්නේ fixed phones ගත්තාම ඒ fixed phone දෙකක් අතර data transmission එකක් වෙන්නේ කොහොමද කියන එක තමයි මෙතනදී කතා කරන්නේ. සාමාන්‍ය මේකෙදී ඔයගොල්ලෝ දකිනවා මේ අපේ ටෙලිෆෝන් එක කේබල් උඩින් කණු වලින් දකිනවා. මේක යනවා distribution point කියලා ඔයගොල්ලෝ සමහරට දැකලා ඇති ටෙලිෆෝන් කණුවක තියෙනවා පොඩි box එකක් වගේ. ඒ box එකේ ඉඳන් underground අපි connect වෙනවා main අපි එකට කියන්නේ exchange කියලා. එතනින් තමයි මේ telecommunications තියන්නේ කියලා. So in this network, usually you can have telephone lines, fiber optic lines, communication satellites, microwave transmission, all these are possible. Right. So let me give you a small graphic where we will show everything. මේකේ ඔක්කොම ටික එකට තියෙන එකක් මම පෙන්නුවා. හරි. එතකොට මම overhead lines යන අපේ ටෙලිෆෝන් ලයින් එක අපි මේක roughly අඳගමු. විභාගෙට මේ ඩයග්‍රෑම් එක ඕනේ හැබැයි ඊළඟ එක ඕන වෙනවා ඒකයි. Right. මේ PSTN network කියලා කියන්නේ පුතාට මම කිව්වා වගේ we have a telephone line. Our telephone, for example, connect through overhead lines like this. And at some point, you will see a box which we call distribution point. And that goes underground. There are some cabinets. Then there are main distribution frame, we call it. And then it goes to exchange. Now, this is the place where it will connect to another telephone. So the another telephone connection is also goes through the same line where you will have another telephone line. They are not connected directly. Telephone line දෙකක් ගත්තාම directly සම්බන්ධ වෙන්නේ අපි exchange කියන එකක් හරහා තමයි සම්බන්ධ වෙන්නේ. අපි මේක roughly අඳගමු. කොට අඳගෙන ඉවර නම් මට කියන්න. So in PST, in public switch telephone network means that additionally our phone lines are connected. So we see that it goes from overhead to the distribution point, and then from the underground we go to exchange. If we want to connect to another phone line, you have to have the same process the other side as well. So we can say this is an interconnected network of telephone lines. So we can say it connects telephones with single wire without connecting each telephones together. So what it means basically to say that the telephones are not directly connected. If that is the case, you will see there will be a lot of connections, isn't it? So the main objective of the network is to transmit voice, voice in currently PSTN comprises of copper telephone lines, fiber optic cables, communication satellites, microwave transmission.
That's right. They in the past also. Yeah, also teaching.
Right. Let's write down how it happens. Now, this is in general. Now, to explain it again, here, this is a network where the phone line, how it is connected to another phone, but it will not directly connecting, but mainly we need to send voice. So usually you have copper telephone wires, so all these wires are coppers. And then when you have underground cabling, usually we have fiber optic cables. If you want to go overhead, like let's say you want to make the international call, then you have to communicate through satellites or using microwave transmission. Right. So let's write down how this happens. So first, what happens? It will actually connects to the overhead lines, and through that it will connect to the distributed point. Then it will underground connect to the cabinet, then main distribution frame, and finally to the exchange, right? So that part we'll take down. So telephone first connect to the distribution point through overhead lines. Usually these overhead lines, you have a copper cables. Then it connect to the cabinet. It goes underground, which you have usually fiber optics. Then it connects to the exchange. Right. Next point, Kanta, we want to discuss how digital and analog are working. Now you see, when it comes to this telephone line, usually it goes like analog signal, right? we discussed in the beginning, analog means the height will vary. Where digital signal, usually you have two heights. Okay. So especially when you work with the digital signals to now computer, we have digital signals. Voice, we have analog signals. So when you talk about these two, then what we want to do is we want to convert digital to analog to send through this telephone line. And the next end, you have to convert again analog to digital. So we use the term modulation to say that you convert your digital signal into analog. Then opposite, that means converting analog to digital, we call demodulation. So the device which actually does this for us is called modem. Modem means modulation and demodulation. Will convert digital to analog and analog to digital. Right. So let's have a subtopic. Modulation, demodulation. And modem. So the term modem actually comes from this modulation and demodulation. So modulation, and then DEM come from demodulation. That's how the word comes in. Right. This is subtopic. So let's look at how this happens. I'm going to use so let's discuss how this happened, modulation and demodulation. So the device I told you, it's a modem. So let's right. So let's say this is a computer which represent this one. So now let's see how the two computers communicate together. So let's have another computer, right? So let's assume that, okay, let's see that how to communicate these two. Now, the problem with this one is the computer operate with a digital signal, isn't it? Computers operate with a digital signal. So it should be a digital signal. So whenever a computer wants to, transmit, we have to check digital. So we have to see how the digital signals, we know high and low. Okay, so in digital means you have high and low.
Mhm.
So the data will transfer.
Aqui, a interrogação que tem uma frente que não vai ver. Ah, hum.
Then we need like some ways of representing this one. We need modem. So modem is a device which connects, right? So we have modem. So the modem means modulation and demodulation, I told you. So using a modem, we can convert, right? So it could be anything like any box shape, right? So let's say we have a modem in between. So this is the modem, let's say. So we have a modem, right? So both sides we have two modems, right? Connecting each other. So in between we have the telephone line. So we have a line in between, right? So the line which connects two modems together. So let's say this modem is connected to this modem. So this is a telephone line, right? This is a telephone line. This is a telephone line. So using a telephone line, it will connect, right? So telephone line connect the two modems. So this is a modem. So this is the other modem, right? And these are the two computers. So let's have the computer. Right? Now, telephone line, what we have is the analog signal. Right? So the telephone line, what we have the analog signal. You know what analog is. So the signal is analog. Right? So we have analog signal. But then These two connections. Now let's say computer to modem, it is digital. Right? So this connection is digital. What computer uses is a digital.
Aqui, não, meio que não meio que fala, né? Aliás, assim, que eu passei a verdade. Color,
So I'm trying to find a digital signal. Show you what we'll have in between computer. We have a digital waveform.
yeah.
You can draw this. I'm waiting to finish only the digital signal.
Oh, No, scratch your beard.
Mm. I
Yeah,
So here I just want to show you that we want to have digital signals in between.
I'm gonna thank you. Mama done it. More than Okay, bye. Thank you, bye. God bless you. Stay safe.
So in between what we have is a digital signal. That's what I want to highlight here. පුතා ඇඳගෙන ඉවරුනාම කියන්නේ. Right. Let's start. Let's write down what is happening here now. Now you can see in modulation and demodulation, basically we have computer, we have digital signal. In telephone line, we have analog signal. So we need a modem device to convert digital to analog and analog to digital, right? So this is the purpose of the models. Let's write down. So now let's look at topologies. We know that physical arrangement of a topology of a network we call topology. So under that, the first one we are going to discuss is called bus topology. So in bus topology, there will be a main wire and all the computers in the network actually connect to the main wire. So in both sides, we have terminators. Right. Now let's write down some advantages. The first of all, when you look at the wiring of the bus topology, the setting up, the length will be smaller. For example, if you compare to star topology, this takes less number of or length of wires. So cost is less and also creation is easy. But if you look at the disadvantages of this one, in other words, this whole network is actually depend on the main wire. So that is one of the issues of the bus topology. If main wire fails, the whole network collapses. So advantages, the length of the wire, the number of wires you need is small, but then again, the whole network depends on the main wire. So these are the disadvantages of bus topology. Okay. The next topology we are going to look at is called star topology. So star topology means the construction of a network is actually looks like a star, which means it's connected to a central computer or a switch. So we can say that in star topology, we will have all the computers are connected to a central computer or a network device. පුතා ලියාගෙන ඉවරනම් මට කියන්න. Okay, so let's draw the circuit for star topology. In star topology, what we need to remember is everything will be connected to a central computer or a network device. So for example, in this case, this could be a hub, switch, or router. Right, පුතා ඇඳගෙන ඉවරනම් කියන්න. Right. Okay, so let's write down the advantages and disadvantages of this technique. Now, when you look at the star topology, you remember that it connects to central one, and this is commonly used one. So the main advantage of this technique is when you look at it, right? It's easy. You can easy to set up, easy to install, and correction also is easy, right? But then there are disadvantages as well. The disadvantages are, right? You need large amount of wires in this particular case. You see, you need large amount of wires. And if the central computer fails, a computer or it could be a network device, it fails, the whole structure fails. So make a note of this. This is very, very important. Okay, let's take down this.